Assalamu alaikum. Midline Properties Part 3. At the end of this video, students will be able to recognize that in a trapezoid, the line that passes through the midpoint of one side parallel to one base passes through the midpoint of the second side. Materials: paper, pencil, ruler, compass, your textbook edition 2012 or 2017. Lines joining the midpoints of a trapezoid. Midline theorem in a trapezoid. Activity: KLMN is a trapezoid such that KL is parallel to MN, H is the midpoint of KN, D is a line parallel to KL and passing through H, O is the intersection point of D and LM. So here we have H is a midpoint, D is a line passing through H and parallel to KL, and O is the intersection point of D and LM. 1. Compare OL and OM by using the ruler to measure. 2. Complete in a trapezoid the line passing through the of one side parallel to one base passes through the of the second side. Please pause the video and try to solve the activity. Solution: 1. By measurement we get LO is equal to OM using a ruler. 2. We have to complete. In a trapezoid, the line passing through the. Here you have a trapezoid KLMN. The line D is passing through the midpoint of one side, which is KN. So, in a trapezoid, the line passing through the midpoint of one side, parallel to one base, passes through. So, line D here passes through O. What does O represent for LM? It represents the midpoint because OL is equal to OM by part 1. So, passes through the midpoint of the second side. What do we conclude from this activity? We conclude that in a trapezoid, in any trapezoid, if we have a line passing through the midpoint of one of its non-parallel sides and parallel to one of its bases, of course, if it is parallel to one of its bases, it will be parallel to the other base, because the bases are parallel. So if we have a line which passes through the midpoint of one of the non-parallel sides of a trapezoid, it will for sure passes through the midpoint of the second side. Can we generalize this result on any trapezoid? Let's see using GeoGebra. Midline theorem in trapezoid. Here we have trapezoid OPSR is the midpoint of OR, D is a line passing through T and parallel to the bases of the trapezoid. Here we have L is the point of intersection of PS and D. As we see here also, we have the length of PL and the length of LS. We see that the length of PL is equal to the length of LS. So, of course, L is the midpoint of PS. Let's move S and change the sizes of PL and LS. They are always the same. PL is always equal to LS. So, whatever the nature of the trapezoid is, L is always the midpoint of PS. So we can generalize the result, which is the midline theorem in trapezoid. If we have any trapezoid, if we have a line passing through the midpoint of one of the non-parallel sides of the trapezoid and parallel to the bases of this trapezoid, it will pass through the midpoint of the second side. PL is always equal to LS, as we see here. So L is the midpoint of PS. So here the general result. In a trapezoid, the line passing through the midpoint of one side parallel to one base passes through the midpoint of the second side. K is the midpoint of AD, D passes through K and parallel to AB and DC, then D will pass through R, the midpoint of BC. Here we have in trapezoid ABCD, K midpoint of AD, D is parallel to AB and parallel to DC. Then, by midline theorem in trapezoid, R is the midpoint of BC. Application. We have here LHPD is a trapezoid. HLD, this angle, is equal to LDP, this angle is equal to 90 degrees. KRCD is a rectangle. K is the midpoint of LD. D, C, and P are collinear points. We have to show that R is the midpoint of HP. So we have to show that R is the midpoint of HP. Please pause the video and try to solve this application. Solution. How to show that R is the midpoint of HP? If we want to use midline theorem, then we have to search for the first midpoint and a line passing through this midpoint and parallel to the bases. Let's see, from the given we have K is the midpoint of LD. So K is the first midpoint. We have to show that the line passing through K, which is KR, is parallel to DP and LH. How to show that KR is parallel to LH and DP? We have from the given also KRCD is a rectangle. So opposite sides of a rectangle are parallel. KR is parallel to DC. But DC and P are collinear. So by collinearity, we get KR is parallel to DP. And as DP is parallel to LH, then KR is parallel to LH and DP at the same time. So now we have K is the midpoint of LD, KR is a line passing through this midpoint and parallel to the bases. What do we conclude? We conclude that R is the midpoint of HP by midline theorem in a trapezoid. KRCD is a rectangle from the given, then KR is parallel to DC, opposite sides of a rectangle. But DC and P are collinear, then KR is parallel to DP and LH is parallel to DP. Since LHPD is a trapezoid, K is the midpoint of LD given. Hence, by midline theorem, in trapezoid, R is the midpoint of HP. Assignment. Review from the textbook, page 93, edition 2012, and page 97, edition 2017. Homework from the textbook, exercise 17, page 99, edition 2012, and exercise 17, page 103, edition 2017. Summary. First, we have the midline theorem in triangle. We need one midpoint and a line passing through this midpoint and parallel to the second side of the triangle. What do we get? The second midpoint. This line will pass through the midpoint of the third side. Converse of midline theorem in triangle. We have two midpoints, the midpoints of two sides of a triangle. So the line passing through these two midpoints will be parallel to the third side. The line segment joining the midpoints of two sides of a triangle is equal to half the third side. Midline theorem in a trapezoid. We have first midpoint and three parallel sides, the bases and the line passing through this midpoint. We get that this line passes through the midpoint of the second side. Thank you for your attention.